So today's topic is NFA with epsilon moves. So you can see this NFA here. You could see that on input is 0. There is a transition from state A to state B and also to state A. So here it is showing the non-deterministic behavior of finite automata, that it is not determined, it is not fixed that on getting input 0 whether there will be a transition on A or B, because it is showing transition on both the steps. Also, if you all know that upon reading the entire input string, if finite automata resides at the final state, then it means that input string is accepted by the finite automata. So, if you want that your finite automata should accept empty string, it means that on giving no input, your finite automata should reach to final state. And this behavior of finite automata, which can accept the empty string, can be showed with the help of epsilon. Epsilon as an input. So you can see that this finite automata or this NFA accepts the empty string. So when there is no input given to the initial state A, you can reach to the final state. So here term epsilon transition means a transition on an empty input. There is no input. So when there is no input, still you can transit from one state to another. And to accept the finite automata, and if you want the finite automata to accept in empty input, then in that case, you can have a transition from initial state to final state on epsilon. You can show the transition from initial state to final state on epsilon. So actually that particular transition, we used to say that it has no length, or it is a path with 0 length. So this is how the epsilon can be used in NFA to show the input, empty input acceptance. Now consider this another NFA which is there, and yes, one more thing, the epsilon transitions are there only in NFA. DFA does not accept the empty input, or there is no epsilon transition in DFA. So if you have multiple transitions on one input symbol, and or if you have a transition on epsilon, then that at automata you can call it as a NFA. Okay, now consider this another NFA. So this NFA accepts have a language, or it accepts the language that will have a set of strings with 0 or more number of zeros, followed by 0 or more number of ones, followed by 0 or more number of twos. So here it means, as I said, you can have 0 or more number of zeros followed by 0 or more number of ones. So when I said 0 or more number of ones, so there can be 1 or there cannot be 1. If I say 0 or more number of zeros, it means there can be a 0, or there can be a 0, or there cannot be 0. 0 or more number of twos is again same. You can have 0 or multiple twos in the input string. So if that is the case, these are the possible strings which this finite automata should accept. So as I said, 0 or more number of ones followed by 0 or more number of twos. It means if I'll say there are no ones and no twos in the string, and it has only single 0, then that should also be accepted by the finite automata, and that is the reason I have shown here 0. So this single 0 should also be accepted by finite automata. It should also accept single 1. It should also accept single 2, and it should also accept string like this 001. then 0122, C double one two, or 022. Likewise, so there can exist zeros, there can or cannot exist zeros, ones, and twos. But if all the three are there, then it should have a sequence: one, zeros, then ones, then twos. So such type of sets strings will be accepted by this finite automata. So when such type of finite automatas you want to design, that time the epsilon moves plays very important role. So epsilons are basically used to make the most complicated design of finite automata a simpler one. So to how, when we have only zero as an input, then how it can reach to the final state, that we will see with the help of this epsilon moves. And here you could see that Q2 is the final state. So when zero is the input, only zero is the input. In that case also, your finite automata should reach to Q2 to accept input zero. So we'll see how it happens. So here you have a transition. Here we are giving zero as input to state Q0. So from this state transition graph, you could see that state 0 on getting input 0, it is transiting to Q0. Then Q0 on getting epsilon as input, it is transiting to Q1. And when you are combining these two, so like if you want to find out the, when you are giving 0 and epsilon, you know, it is no input. So if you say, if you want to combine these two, so your statement will be like this: you want to find a transition from state Q0 on input 0 and epsilon. So it is bifurcated like this: Q0 on getting input 0, its transition you have to find, and whatever is the answer to that, you should give epsilon as a input. So Q0 on getting input 0, you know that it is moving to Q0 itself. Then Q0 on getting epsilon, it is moving to Q1, right? So here you can say 0 epsilon. As I already told you, 0 is nothing but the empty input, or there is no input. So 0 with epsilon, it means 0 is concatenated with empty string. So 0 epsilon is also equal to 0. And that is the reason, if you could see this particular statement, when we have evaluated transition from state Q0 on input 0 epsilon is also equal to giving a 0 input to Q0. Okay, so from these two equations, this particular equation and this particular equation, if you could see, the meaning is what? There is a transition from state Q0 on input 0 to state Q0 and Q1. Similarly, you can prove this when Q1 will get input 1, and you could see that there is a transition from Q1 on input 1 on state Q1 and Q2. So you could see that here again on input 0, there is a transition from state there is a transition from state Q0 on two different states, that is Q0 and Q1. And Q1 on getting input 1, there is a transition again on two different states, that is Q1 and Q2. So here also this automata is showing is non-deterministic behavior. So we can call it as a NFA. Okay. Now again here we have a same problem, that we want to design a finite automata that will accept the string with zeros or more number of zeros, followed by zero or more number of ones, and followed by zero or more number of twos. And this automata which is shown here, this NFA, it accepts the given language. And how it accepts that we will see. So see here, the third point here, let us check whether NFA accepts a string epsilon. So we will start from the initial state. So Q0 on epsilon move, it is moving to Q1. Then Q1 on epsilon move, it is moving to Q2. So it means, I'm sorry, I guess here it is. Q0 on epsilon, it is moving to Q1, and Q1 on epsilon, it is moving to Q2. So it means if you'll give epsilon input twice to Q0, you will move to Q2. So 2 epsilon, it means epsilon, epsilon, 2 empty inputs. If you are concatenating, it is finally, it is going to be the single input, empty input. And hence you can say that Q0 on epsilon is equal to Q2, and which is nothing but the final state. So here it means that if you are starting with your initial state Q0 and on reading input symbol, you can reach directly to the final state Q2. It means this finite automata accepts input string also. Now, if you want to check if it accepts this input 002, so definitely the first input symbol will be given to the initial state, which is Q0. So let's give 0 as input to Q0. So from state Q0 on input 0, you're transiting to Q0. That is the reason you could see here. Now you will give another input symbol that is next to second, next 0, that is second input symbol again to Q0, because currently you are on state Q0. So again on getting input 0, there is a transition from state Q0 to state Q0. Then Q0 on getting epsilon input, it is moving to Q1. Again, Q1 on getting epsilon input, it is moving to Q2. And Q2 on getting input 2, it is going to Q2, which is the final state. So what is the sequence of inputs which we have given if you start with the initial state Q0? So you could see that here you have given 2 zeros as an input, then 2 epsilons as an input, and finally you have given 2 as a input. So 2 epsilons, it means there is no input. So 0 0 epsilon epsilon 2 is equal to 0 0 2. So after giving this input, if you are reaching to Q2, it means on giving 002 as an input, you are reaching to Q2, which is the final state. So it means that 002 is a string which is accepted by the finite automata, because when it was processing the last input symbol, you were at final state. And that is the reason, as I said earlier, NFA with epsilon moves helps to split a complex language acceptance problem into smaller ones. Now, if you want to design a state transition function, state transition table for the same problem, for the same NFA, then here you will have to, along with 0, 1, and 2 as a input symbol, you will have to add epsilon also, because you are giving the epsilon is also one of the input symbol in your NFA. And if you'll see the state transition function here, along with the input alphabet, you have to add this epsilon as the one more input symbol. You have to add this in your input alphabet. And that is the reason here you can see the column 0, 1, 2, and the epsilon. And all those transitions which are there are shown here. So Q0 on getting input 0, it is it can transit to Q0 and also to the Q2 final state. And on input 1 and 2, there is no transition. Q1 on getting input 0, uh, there is no transition because Q1 is not accepting 0. On 1, it is moving to 1. There is no 2 as an input to Q1. That is the reason here it is pi, and Q1 on getting epsilon, it is moving to Q2. And to Q2, there is no input Q1 and Q2. And yes, there is a input 2 to Q2, and it is transiting to the same state. So this behavior of NFA, you can show this behavior of NFA, you can show in state transition table like this. Okay. Now, next, more another important concept is epsilon closure of the state. So, epsilon closure of a state, you need to find this epsilon closure of the state when you have to convert the NFA with epsilon moves to NFA without epsilon moves. So, what is epsilon closure of a state? So, basically, it is a path from state A to state B on epsilon as a input symbol or on empty input. Epsilon closure is nothing but the transition from state A to state B on empty input or on epsilon input, epsilon as a input. So, if we'll say the epsilon closure of Q0, if I'll take the example which we have already covered. So, if I consider this NFA, so here epsilon closure of Q0 is what I can move on empty input from Q0. I can move to Q1. Again to Q1, there is a epsilon transition and you are moving to Q2. So on epsilon, if you will see, from there is a path from Q0 to Q2. Right. So that is a reason on epsilon input, definitely you can move to Q1. And it means all the states which are in this path of epsilon, all those states you should add in the epsilon closure of Q0. So if you would see this path contains, it is starting with Q0. When you are giving epsilon input to Q0, you are moving to Q1. Then from Q1 again on epsilon, you are moving to Q2. And that is a reason Q1 and Q2 are in the epsilon closure of Q0. Also, Q0 itself is at 0 distance from the state Q0. And that is the reason Q0 is also added in the epsilon closure of Q0. So, any state is at a 0 distance from itself. And that is the reason that state you should add in its epsilon closure. So, if you follow that rule, you can see that epsilon closure of Q0 is Q0, Q1 and Q2. Similarly, if you could say epsilon closure of Q1, so there is a path on epsilon move from Q1 to Q2. That is the reason Q2 is added in epsilon closure of Q1, and Q1 itself is at 0 distance. So Q1 is also there in the epsilon closure of Q1. And epsilon closure of Q2 is Q2. Okay, so separate notation which we are using for epsilon closure is this you can see here, this delta, and on that this symbol we should put to just to understand, just to make it clear that we have to the meaning of this is epsilon closure. Now, if you want to convert this NFA, or if you want to find the equivalence between NFA and NFA with epsilon transition. So equivalence, find out when you're finding out the equivalence between two, it means both the NFAs with epsilon or without epsilon should accept the same language. So for that, to find the equivalence, there is a NFA named as M1, and these are the tuples which are shown here. The meaning is same as what we have learned earlier. Only the difference here, the delta or a state transition function here, to that, uh, here we are mapping this q with the input symbol, and to this input symbol we need to add the epsilon also, and it will map to the 2 raised to q states. And now if you want to convert this M1 to the NFA without epsilon, then we will name that resultant NFA, which is without epsilon, as M2. And M2 will also have the same set of tuples here, Q, sigma, delta dash, Q0 and F dash. So from here you can observe that the set of states, that is Q, then set of input symbol, that is alphabet, and Q0, which is initial state, that will remain same as NFA with epsilon. Here delta dash of NFA without epsilon moves will be different than the NFA with epsilon move, and state of final state can also vary, and that is the reason here it is marked as delta dash and F dash. Okay, now how you will evaluate, or what is your delta dash of the resultant NFA. So delta dash, it is represented here. So if you have some state Q in a resultant NFA, and A is the input symbol given to it, then how you will convert this, how this E state you will convert to NFA without epsilon transition. So for that, what you have to do, so you have to follow, or you have to use this formula. So epsilon closure, and inside this epsilon closure you have to find the epsilon closure of Q on epsilon moves, and whatever is the output, to that you should give A as the input. What your output you will get, you have to find the epsilon closure of that. So here is the example with the help of which you can you will understand. So again here it is the same finite automata. You know that this finite automata, it accepts the length which consists of strings where 0 or more number of zeros followed by zeros or more number of ones followed by 0 or more number of twos. And as we have discussed earlier, the epsilon closure of Q0, Q1, Q2 for this finite automata is this. So this we have already evaluated. Now Q0 is at 0 distance from Q0 and Q1, and Q2 is the only final state in the given NFA, and that is a reason from this observation, if you could see, it means that there is no path, zero path between Q1 and Q2, and there is a zero path between Q0 and Q1. It means there is a zero path between Q0 and Q2. It means all these states will act as a final state, because if it is same, or if there is no path, it means Q0, it means Q2 and Q1, it is same because there is no path. It means that Q1 and Q0 is also same, there is no path. So if Q1 is a final state, Q2 will also be a final state, and that is the reason in the resultant NFA, sorry, Q0, Q1 and Q2, all the three states will act as a final state. Okay, so now let's give input 0 to state Q0. So applying the formula which is, sorry, which is given here. So applying this formula, I want you all to take a note of this formula. And so delta dash Q0 on 0, we'll apply the same formula here. So here it will be Q0, here it should be Q0. epsilon closure delta, then epsilon closure Q0 epsilon on 0. So epsilon closure of state Q0, you know it is Q0, Q1 and Q2. And to this state you are giving 0 as an input. So you know how to solve it, as we have done, as we have seen this in earlier problems. So when it is the case, you are giving 0 input to all the states which are in the curly braces, and we will be taking the union of its output. So Q0 0 to state Q0 you give 0 as an input, to Q1 you give 0 as an input, to Q2 you give 0 as an input, and take the union of all. So final output, it is Q0, and finally you have to again find the epsilon closure of Q0, which is Q0, Q1, Q2. Likewise, you should give input 1 to Q0 and compute your delta dash for state Q0 on input 1. Then compute your delta dash on state Q0 on input 2. And then again, you have to repeat the same thing. That is, you have to compute the delta dash on Q1 for input 0, 1 and 2, and compute your delta dash on state Q2 for input 0, 1 and 2. And you have to use the same step. Here you should use the same formula. And once it is done, then we will draw the state transition graph, where you will see that it contains no epsilon transitions. So that way you can remove the epsilon moves from the NFA. So likewise, we have to give input 0, 1 and 2 to all the states Q0, Q1, Q2, and the final output will be this. So Q0 on getting input 1, you could see the transition is on Q1, Q2, Q0 on getting input 2, it is transiting to Q2, Q1 on getting input 0, transiting to empty set, Q1 on getting input 1, transiting to Q1, Q2, Q1 on getting input 2, transiting to Q2, Q2 on getting input 0, transiting to empty set, Q2 on getting input 1, transiting to empty set, and Q2 on getting input 2, transiting to Q2. And depending upon that, you can see here the state transition graph can be drawn, and state transition table is also shown. So applying this, you can design the state transition graph and state transition table.